that aren't data-oriented do care, it becomes much less of a clean, system. Like you really need to design around that almost, which is kind of a pain. But like for templates for my thing, right? Like I can't just if I have an actor and I want to compare it to another actor, or like an actor template, and I want to say, oh, is this live actor the same as the template? Without necessarily looking at the template thing that it has, right? Like if I'm trying to save all that data back, I want to see if any of the stuff's been modified. I can't just create a new instance of that template in my data structure, right? Because it's difficult to, well, it's not difficult to remove, but it's like, I would have to, vectorize it and put it in the thing and do all this stuff. It's just not as easy. I mean, you could do it. It's just not.
It turns into a gigantic mess.
It's not very nice looking or feeling.
All the bookkeeping and administrative stuff.
I mean, it's good. It's fast, but...
we got a student that is taking us to the 440 website. That's cool. That's awesome. The poster in their P1 takes you to the 440 website.
Oh shit, I have OS, I gotta go.
Alright, see you.
See ya. Crap, sorry.
Okay, ladies and gentlemen, thank you for joining us for another week of EECS 440. Okay, it's good to see you. It looks like a lot of you are working on your project ones. You've got them open right in front of me. That is what the laboratory is for, so good stuff. Your P1 Alpha was just due 5 minutes ago. How'd it go? We had a team come in hot, 1:29 p.m. All right, just at the last moment. All right. How did the assignment go? P1 Alpha has some tricky tasks, right? Very tricky tasks, actually. Okay. One of those tasks, for instance, the whiteboard, right? A little bit infamous because you need to actually go in to the architecture of your project. You have to understand it. You have to understand how the VR pawn works with that line trace going out with the afforded system, because you need to basically take that interact function that's really nice. You just click and something happens. And you need to make it like, oh, I can hold now. And it's just automatically so you can draw right on that whiteboard. There's a lot of things you need to do like that. Time of day has you grabbing objects, actors, and then grabbing unique components on those actors. The NPCs. How many of you got the NPCs done okay? All right, that one was a bit tough, right? You're dealing with UI, the new UI system. You're spawning text above the actor's head. You're trying to get the NPC to detect the players nearby, and also turn the NPC to look at the player. There's a lot going on with a lot of these week 2 P1 Alpha tasks, okay? And so, if you didn't get them all complete, if they're not all polished yet to the letter of the spreadsheet, then you've got another week, okay? In fact, you got more than a week. You've got a good bit of time now. You have 9 days to complete all of those tasks that you see in the spreadsheet, because at the end of P1 Gold, you're going to be graded on them wholesale, okay? So we want to see them done. We want to see them complete every feature listed, and we want to see them bug-free, okay? You're also, during P1 Gold, going to need to do what? What's that unique thing about P1 Gold that you got to do? It's like there's something extra, right? A little something extra. What do you have to do? Yeah.
Create object and interaction.
Yeah, custom object and a custom interaction, okay? And why are we doing that? Well, you're really probably wanting to make this project your own, right? This is supposed to be your project. This is a capstone course, a design course. And up till now, you've all been making the same tasks as part of your learning process, but it's time to create something of completely your own design now, okay? And so you'll get a chance in this final week and a half to make something that you want to make. And it can be very substantial, okay, or it can be relatively small. In fact, I would like to show you some examples, just kind of remind you of what they look like. About the minimal thing that we want to see, right? We want to see an object and an interaction that involves a bit of technology, okay? A little bit of new logic, some new objects, okay? Did I show you the hidden beer pong minigame? So this is the beer pong minigame. We're in the Beister building laboratory. When I go through this caution door, I get to a little secret room that has beer pong. Now this is implemented with beer pong. You see there are gameplay mechanics. Okay, when the ball hits the ground or misses, we get it back. It respawns, very convenient. Yay! Okay, when we hit a cup, the cup goes away, right? And you get a sound effect, okay? So it looks very simple. It's a very simple idea, but there's a little bit of custom logic in here, and that's really what we want to see. As far as how big does my idea have to be, this is a good size, okay? Not super big, but not super small either. So you're looking at something of this size. Energy drink that just changes your vision. It's a little bit small. You want to be a little bit more than that. I'll tell you, this one, the Matrix Red Pill, is way overboard. You don't have to go this crazy, okay? This involves a custom map, a completely new map that you get warped to. And when you click on the red pill over there, you discover that it is the Matrix. You can see the dystopian destroyed city in the background, and you can actually fly. So your controls have changed. There's also I think there's a phone booth somewhere in the city that will return you to the main map. So yeah, quite a few things in this scene. Pretty cool. I definitely went overboard here. Flying through the city, right? I feel like this would make you motion sick, possibly. But extremely cool stuff. Let's see if they end up finding the phone booth. Do they land? Can they land on a building? Oh, that is super, super cool. So they've got the collisions working. Okay. Oh, they find the green orb. Okay. I don't remember that in the movie. Thanks for playing. Okay, great. I would have probably made it a phone booth. That's what I thought it was. Okay, cool. Anyway, so you can look at these examples in here, and you can make this as big or as kind of well-scoped as you want. And the grading on that custom feature, not super hard, okay? But for the rest of it, it's going to be harder, okay? Because we really want to see those standardized tasks in the spreadsheet be finished. Okay, so I want to show you a company before we really get into it today. Today is going to be about kind of talking you through the idea of composition, components, right? Components. What are they? Why do we use components in all of our game engines, okay? You've probably written a bunch of components for your P1. Now, if you derived that component from an affordance-based class, you've got an affordance component, which has that nice interact function. But I'm going to talk more about components and why they matter, all right? So we've got this company right here called Obsess AR, okay? And it's a company that has taken in about $13.5 million in funding. It is based in New York City, which is an expensive place to put yourself. You better have a lot of funding if you're going to be chilling in New York City. This is the virtual reality experience platform, okay? So an AI-powered interactive 3D solutions for web, Roblox, and gaming platforms. Note, this right here, do you see this that I've highlighted? That wasn't there last semester, okay? So suddenly we've got this startup that, oh yeah, we're AI-powered now, right? You know, I'll bet 3 or 4 years ago they had blockchain in their website, and probably that's now gone. What does this tell you when you notice a company over time kind of changing and incorporating new terminology? What does it suggest to you about the company, or even about the fundraising game in general? Yes? Yeah, it could suggest a lack of progress or a lack of traction, okay? It could suggest that they're just chasing trends, okay? And their true business model is to figure out what investors are getting excited about in any given moment. And hey, if people are excited about AI, if that's going to help us raise money, we're an AI company now. We'll retrofit AI into our product somehow, and there you go. And so you have to be careful about that. A lot of startups, right? Are just hopping from trend to trend. I'll tell you a quick story. So one of my good friends goes to San Francisco fairly often. He has one of the larger gaming companies in the state of Michigan. And he told me that he went to San Francisco and he was talking to companies that would call themselves something like, blockchain entertainment, or, blockchainopolis, right? And their actual product would have no blockchain at all, right? They would just kind of slap blockchain right on the side of the product and then forget about it, so that they could add it as a bullet point onto their PowerPoints, right? Yeah, we're a blockchain company. Why did they do this? Because if they do have that bullet point, they get lots of easy funding. If they don't have it, they get nothing, okay? And that's the kind of state of fundraising, right? If you are a trendy topic, then investors will rush at you to throw money at you. And if your topic is out of fashion, not so much, okay? I will tell you, it's very hard to raise money if you are a game studio right now. But you know how to raise money and improve your odds by 1,000%, probably. Describe yourself as an AI game studio, okay? Oh, we're going to use AI to build NPCs. We're going to use AI to automatically generate new adventures for our users. Now you can raise money much more easily, okay? So it's a little bit sad sometimes. Anyway, that's how it is. Okay, so this is a company, Obsess, that is trying to be more of a platform. Remember, investors don't get excited about a product, a singular product. They want to be a platform that other companies stand on top of so that you can then tax them, okay? And this is a company that is a bit of a consulting firm. So you can hire Obsess AR to build your VR or AR or gaming experience for you. Look at this right here. One of their clients is Sam's Club, you know, the Costco rival, a grocery store, basically. Do you think that Sam's Club has a dedicated technology team? They probably do. But is it going to be huge? Does that technology team include VR and AR specialized developers? Probably not. That's just not Sam's Club's business, okay? They don't do VR and AR and gaming stuff, okay? So if Sam's Club, if their marketing team really wants to have a VR or AR store or experience or something like that, they don't have the personnel to do it themselves. So what do? They go out and they find a third-party supplier like Obsess. Obsess is a consulting firm. They are a mercenary group. You can hire them and they will build a VR or AR experience for you, for your brand, okay, when you can't do it yourself. And so they have a lot of stats here, right? You can tell who they're targeting, right? Hey, grow your customer engagement, okay? 140 million plus consumer interactions in Obsess-powered virtual stores. This is suggesting that, hey, the virtual stores that we make, consumers do a lot of stuff in them. They love going back to them. Now, one question is, what on earth does an interaction mean? Okay, because you can juice those numbers if you keep them poorly defined. Drive brand equity and loyalty, 10x higher time spent than traditional e-commerce for a leading consumer goods brand. So for one of our brands that we partnered with, for one of them, that's immediately spooky, right? They saw statistics that said, hey, people are spending 10 times as much time in this VR experience than on a web page. Okay? Now, I've got a question for you. They don't go much deeper, and possibly for reasons that might not be very fortunate. How long does it take to put on a headset? How long does it take to get the headset off? Compare this to the act of clicking a new button in your browser. And you can see that it doesn't take a whole lot for a VR experience to sync about 10 times as much for a similar engagement as a website. So is this really saying that people love our virtual reality stores and they engage better and it's going to be impactful? Or is this a little bit suspicious? Okay? It's hard to tell. They don't give you additional data, at least that I can see. And so you got to be careful, all right? Okay, blah, 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 all this stuff. That is to remind all of you that when you are trying to validate and verify a startup or a business idea, if you're trying to figure out whether a company like this is succeeding, okay, you're going to look at a lot of biased data, okay? The startup is not incentivized to give you a true, very transparent look at the situation. No, they want to give you the rosiest tinted glasses that they can possibly come up with. So you have to be very careful. Okay, if you find yourself choosing someone to partner with, or if you become an investor yourself and you're choosing who to invest in, you got to be very, very careful. If you yourself are a company, you might find yourself dipping into some of these strategies, or if you go the honest route and you just be very, very transparent, you might find yourself struggling. Now, I would respect you if you did that, but and I'd want to work with you, but Yeah. So anyway, this is a platform that gives you a lot of things for free. This is a company that will use their technology, which already has built-in transaction functionality, so people can actually order things in the virtual store if you want. And they will do all of this stuff without you having to pay a whole lot of money. They'll create the space, they'll recreate a store. I guess you send them some of your marketing or reference material. Players who arrive are able to enter with a custom avatar and stuff like that. You just get all this functionality for free, okay? And so, kind of cool stuff. And it looks like they have a lot of partners, so good on them. They can do games, they can do quizzes, virtual events. Sometimes when you think to yourself, I want to create a big VR or AR or game product, you say, I'm going to take it directly to Steam or itch.io. I'm going to go directly to consumers. They're going to love my characters. They're going to love my game. They're going to pay me directly. If you can make that happen, good for you. It's a great approach. But it's super risky. It almost never works, okay? Thousands of games coming online every single day. Yours is going to be the one that succeeds? Are you sure? Well, another way to consistently make money is to say, you know what? I'm going to make games for businesses, or I'm going to make games for the government, and then the businesses will take on all that risk, okay? If I make a game for, what is this brand right here? Benamart? Has anyone heard of Benamart? No? If I make a video game for Benamart, and it goes out and sells 0 copies, how much money do I make? I make a good bit of money. However much they paid me to make the game. I still get paid, okay? But does Benamart get paid? Nope, not at all, okay? So anyway, this is a business model that can be very successful, and Obsess has been around for a long time, for 3 or 4 years at least. So maybe they've got something going. So good for them, okay? Virtual commerce and retail spaces for brands. They make it easy. So when Pepsi comes a calling and they don't have any engineers who can do this stuff, then you can make it happen. Yeah. Okay. A reminder, Stephanie O'Malley, the fantastic leader of our Duderstadt Center here and our emerging technologies team, basically the people who run the laboratory we enjoy here, has an opportunity for you, okay? If you're looking for a job opportunity, hey, pretty much no one knows XR as well as you all are going to. In fact, probably you're some of the best XR devs on campus already, and we're not even finished with Project 1. So this is going to be a great opportunity for you if you want to possibly get a role. Develop an augmented reality mobile app for the Trotter Multicultural Center. That's going to be Project 2. Basically, we're going to teach you how to do that in just a few weeks. Position begins in the fall of 2025, so September 2025 probably. $20 per hour, 15 to 10 hours per week. This is a good thing you can slip in there if you've got a lighter course schedule. Just finishing up some courses, that'd be a great thing. You'll learn a lot. Required qualifications, desired qualifications. You're going to be learning a lot of this. So send your portfolio, apply here. I'll put in a good word for you if you let me know. Yeah, this kind of thing, like working for a university, can help you get letters of recommendation, can help you get into graduate school much easier, can help you meet people, so I recommend it, okay? Give it a shot if you've got the time, okay? Professor Niebling, who runs the really cool MI2 lab, the UMSI Interaction Laboratory, Professor Niebling is always creating kind of new, unique technologies that allow people to kind of collaborate in VR, in XR. This laboratory is often looking for people to help them out. You can look through this webpage. If you go find the link, join the team, and he can definitely help you get into grad school if that's a focus for you, okay? He's a research professor. I am not, okay? My letter only goes so far. His letter would go much farther, okay? And combined, you've got a very good chance of getting into grad school, okay? So anyway, take that in mind. I can't remember if I showed you this. Did you know Apple has their own game engine? Did I show that to you? I did, okay? Oh, I already did. All right, that's all to say Unity should be very flattered. They basically just stole the design, and as far as I can tell. And Apple has so much money, I'm very surprised they didn't just buy Unity out, especially as Unity has been struggling the past couple of years. Their stock price is through the floor. Be a pretty cheap acquisition, okay? Anyway, could have antitrust scrutiny if they did, so maybe that's why they didn't. Some quick tips to remind you of for P1. Often, we'll want the code within our components to be kind of able to reference the actor that we're on. We're going to talk more about components in just a moment. But the whole thing about components is that you can mix and match them. You've got an actor, like a character. Well, you can put any amount of components in any combination onto that actor, and the components make the actor do things. Right? You can remove the component anytime you want. You can add on more components. You can mess with the components. But often, in order to do their job, the components have to get a reference to the actor they are on. Okay? And so the component can get that actor that they're currently on by using the getOwner node. Okay? So that's something that confuses students a lot on Project 1. They're programming some logic, but they forget where that logic is sitting. So sometimes in this project, you're going to have to use getOwner to get the actor that we're currently on. And then once we've got the actor, we can use a node like getComponent by class, okay, to get a different component on the same actor that we are currently on, okay? And so that is something to keep in mind. It might help you out. When you want to communicate between components, you can call a function or grab a piece of data on another component. You can use the getOwner node, okay, which we just talked about, to get the actor, and then use the getComponent by class node, right, to get that component you want to mess with. Then you can tweak variables, mess with things, whatever you want. Remember that we wrote some big functions in one of our previous lectures, the Programming in Unreal lecture. And if you ever get confused about some really, how do I do complex stuff in Unreal, that example, find all node tie lovers, is going to be something that helps you out a lot, okay? All right, so let's go ahead and get to it. This might be a little bit of a lighter and faster lecture today, but we're going to get into it. When you look into Unity and Unreal, the way we program in these two environments is component-based, for the most part. You might have noticed in Unreal that you can put logic into a component, but you can also put your logic directly onto the actor itself, if it's a blueprint, right? I highly recommend you do most things by just creating new components, as that promotes code reuse. But basically, you've got components everywhere you look. This trash can actor has two components, a static mesh component, which does physics and collisions and rendering, and the AF toggle actors component, which is an affordance that allows you to turn things on and off. In Unity over here, we have way more components. We have a game object, an actor called security turret, has 1, 2, 3, 4, 5, 6, 7, 8 components. Okay, quite a few. Quite a few. And so let's talk about components. Let's talk about those today, all right? I want to show you a project that is absolutely amazing. It is a technological engineering marvel, okay? It was made by Warner Brothers, of all companies, okay? And a team called Fifth Cell. I like how they play the warm little jingle, but only when their logo shows up, right? Not when Warner Bros. Shows up. Okay, maybe a little bit of consternation there. So here's Scribblenauts, okay? This is a children's game. It's a game where you solve puzzles using a special power that you have. Are you ready to see what it is? Someone give me a word. Any word. Give me a noun in particular. Car. I need a car to solve my puzzle, so give me a car. And you know what? I can even drive the car. Okay. I need another word. Yes? Jetpack. Jetpack. Any special kind of jetpack? Like you want a really big one? So I want a big, icy jetpack. A big jetpack made out of ice, just like that. Let's use it. Oh, can I put it on? Oh, I think it's too big for me. Oh, no, I can use it. Here we go. And now I can fly. Amazing. What else? Yes? A robot. What kind of robot? Give me some adjectives. Humanoid robot. I don't know if that one's going to work. Oh, all right. Oh. And it immediately jumps in the car. Okay, I need something scary. How about Cthulhu? Okay, here's Cthulhu. We need to defeat Cthulhu, okay? Oh, they're going to fight now. All right, the robot, uh-oh, not going well. Uh-oh. We're going to have to deal with this. How are we going to deal with this? I want a vampiric fire bazooka. Oh, a fiery bazooka. There we go. Okay, so it's hurting me, so we need to use it soon. Oh, and I just blew myself up. Okay? But you see the amazing technological work here, right? This is a game that has every word in the dictionary, pretty much, in it, okay, as a physical object that you can use. In fact, it even supports adjectives, okay? A seemingly unlimited number of things are in this game. And you know what's most amazing? This game was made by a small team. I think they only had about 50 people, okay? And yeah, some of them are going to be engineers. Some of them will be artists, but we're talking like probably 10 to 15 engineers, okay? Probably like, 15 to 20 artists, all right? Absolutely amazing. Amazing. So technologically, as engineers, what we have to be wondering is how on earth did a team that small create a game so big, okay? How did they do it? How is it even possible, all right? And so we're going to talk about the composition pattern, and we're going to talk about why it is so common in game engines, what components are, why you should care about them, why, in my opinion, it's usually better than inheritance, okay? You all learned about inheritance in EECS 280, right? Okay, now I'm going to teach you the next step. So let's see here. This is Scribblenauts, okay? A 2009 game is created by Fifth Cell and Warner Brothers. The idea here is you can create any object by typing it. And we really mean any object, okay? If you type something like a professor and you hit the enter button, you end up with a professor, okay? If you type jackalope, do you know what a jackalope is? A jackalope is like a mythical half bunny, half deer. It's this, okay? If it's a word, if it's in the dictionary, there's a good chance the game recognizes it. So there's your jackalope. And that's really amazing. How did a smallish team build something like this? And when you look at games, when you look at game engines, right, this kind of game was built using something called composition. It uses a lot of components, okay? It uses the kind of things that if you were in game engine architecture, you would be building yourself, okay? They used composition, but what is that? Well, it's a method of code reuse. Now, currently, how do you know to reuse code? What methods of code reuse do you currently know about? What did you learn about in 280, 281? Yeah. Methods, functions, absolutely. That's a classic, right? One of the first ways to reuse logic. But there are other ways. What else did you learn? Yes? Inheritance, right? Classes. The idea that you're going to create all these different types of data, types of objects and actors, and you're going to have them inherit things from each other so you don't have to write it twice. Super powerful, super useful. Let's talk about inheritance, okay? Everyone's favorite. It's a very popular method of code reuse. It has wide support. If you have a programming language, it almost certainly supports inheritance. The usage looks something like this, okay? You have an inheritance is a tree and is a hierarchy. okay? You might have a default object that's very abstract. It doesn't have a whole lot in it. You might have a human and a rabbit both derived from object, okay? But there are multiple different types of humans. So a professor is a specialized human that has a few additional things and some tweaks, okay? A student is also a human that has its own different additions and tweaks. A rabbit, right? A jackalope would be a specialized type of rabbit, okay? And in C++, if you want to do inheritance, you've already seen this example. You write it up about like this, okay? So, anyway, let's go ahead and if you look, right, let's see here. Okay, if you look at this scenario right here, imagine for a second that you've become a developer. Congratulations, you got that game dev job right out of college. Very difficult to do so. You've gotten a great job at a game studio. Now, your boss comes in one day and says, hey, welcome to the team. Your first mission is to design a panda. I want a panda game object, okay? So you start working on the panda. And you know that your boss is going to ask for additional features soon, okay? They might ask for a normal bear or maybe a reptile. So you set up an inheritance hierarchy that looks like this. Does this make sense? You've got a panda, but that derives from bear. Bear derives from mammal. Mammal is a living entity, and living entity is an object, okay? So you have different functionality and data and features and functions at all these different levels of your inheritance hierarchy, all these different classes, okay? That's going to save you a bunch of time in the future because the next day, your boss walks in and says, hey, the film Frozen just came out and icy things are really, really trendy. Quick, we need to make an ice panda. So what do we do to very quickly make an ice panda? We want to reuse as much stuff as we can. We don't want to have any duplicate logic or data anywhere in the chain if we can. What do we do? Where does ice panda go in our hierarchy? Come on, let's go. This is not hard. Yes?
It goes next to panda, sort of.
Yeah, it's going to go underneath panda, right? Because we want to reuse all the functionality of panda, but we want it to be an icy panda, right? So little tweaks to the panda class. Thus, we have an inheritance hierarchy that looks like this, okay? Really simple, right? Easy. The next day, your boss has been grinding a bunch of horror stuff, okay? Watching horror films on Netflix. And he says, I want a Lovecraftian panda. This is a panda that has kind of zombie skin, and it has the ability to fly, okay? So it's kind of an eldritch panda. So where are we going to put that in our inheritance hierarchy? And for those of you who can't see, because my display, I'm going to turn this off, so you can see a little bit better. There you go. Where are we going to put this eldritch panda in our inheritance hierarchy to reuse as much logic as possible? In the panda, right? Yeah, absolutely. So we're going to put it underneath panda as well. It is now a sibling to ice panda. That's important. We don't derive from ice panda because we don't want any ice logic in our eldritch panda. That doesn't make any sense at all, okay? And so things have gone really well thus far. Inheritance is really great, isn't it? But suddenly, one day your boss walks in and your life will never be the same. Because the thing he asked for today is the ice snake. And you don't know it yet, but you're in big trouble. Okay? Where would you put the ice snake? Yeah. You would put it under living entity, maybe. That's something you could definitely do, okay? Here's some ideas for you. How about, I don't know, you put it under the ice panda because you want to have the ice logic reused, right? But wait a second. This makes no sense at all. This is an awful decision. okay? Because now we have a bunch of panda logic inside of our ice snake, okay? It's going to be hideous. It probably won't work at all, okay? Well, what if you did this? Let's create a reptile category, right? And we'll go ahead and create a reptile, and that's, snake under that, and then an ice snake, right? Isn't it great? This is not great, okay? What is the problem here? You have violated a principle called dry. Don't repeat yourself. I think I've talked about this before. Do you know what dry is? Don't repeat yourself is a fundamental principle of programming and information that says you don't want to duplicate things, okay? You want to have a singular authoritative source for your logic, for your configuration, for your actors, okay? What happens if you have a bunch of code copy-pasted in one class and you just copy and paste it to another class? Have any of you ever run into a copy and paste bug where you have some logic, but instead of creating a function or a class or something, you copy and paste it a bunch of different places, the same logic in a bunch of different places. Oops, one day you discover that there's a bug in it. Unfortunately, you pasted that logic in 5 different places, but you only remember to fix it in 3. Now you're toast, okay? You've got 2 hidden bugs that are going to cost you many hours now to flush out and find, okay? And it just keeps getting worse the more copy and pasting that you do, okay? Dry. Don't repeat yourself. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. In this case, we don't want you copying and pasting or duplicating functionality, okay? If you keep to dry, then it will reduce your copy and paste bugs. It'll make it much easier to maintain your code, okay? This is what good architecture looks like. You avoid duplication. Okay, avoid placing redundant functionality into multiple locations of your inheritance hierarchy. So this is probably the best solution that we're going to be able to come up with, but it's not good, okay? It still stinks. It has a major problem, all right? You could create an ice object category, but then you still have the same problem. You're still violating dry, okay? And so it's a huge problem, all right? What happens if during gameplay we want the ice panda or the ice snake to melt and just become a normal snake or a normal panda? Can you usually change your inheritance hierarchy during runtime? No, that's not usually a thing you can do. Okay, I think some languages that are very dynamic, like Lua, you can do that. But normally you can't, okay? Not in C++ anyway, all right? So the situation here is that we're just chasing our tail, okay? We can't really get a good inheritance structure that isn't violating dry and, one that makes sense, one that feels good, okay? So we're chasing our tail here. We need a better solution. And this is the kind of situation inheritance trees can get into, okay? How many of you have ever tried to sort photos? Or you've got a bunch of files on your desktop trying to sort them, right? Imagine that you're sorting photos on your computer one day into photos of boats and photos of cars. And it's all going super well until you get to this photo. Where do you put this photo? Where do you put it? Because no matter what choice you make, you're going to feel very awkward as you do so. There is no good answer here. What you're probably going to do is you're going to take this photo and put it into one or the other, and you just kind of hope that you remember which one you put it into later, because it could reasonably be in both. Okay? Big problem. All right? Big problem. Anxious. So one thing you might decide is that, what we really need to do is inherit from multiple classes. I want to inherit from a reptile class, but I also want to inherit from an ice object class. Thus, I get the properties of both without making things nasty. Okay? Something like this. All right? What you should know is that this feature called multiple inheritance is banned by a bunch of the world's most popular and influential languages. So if C# and Java and PHP really don't want you doing this, you should probably ask yourself why. okay? C++ will let you do this. Python will let you do this, okay? But why is it so contentious? Well, this is something called the deadly diamond. Imagine this situation right here. You've got a human, okay? And that human has a function called sleep. Now, we've got a class called student that inherits from human and changes, overrides that sleep function to do some other stuff. You've also got an instructor class or a professor class that does the same and overrides sleep, okay? And then one day you have multiple inheritance, so you have someone or some class that inherits from both of these things. So the question is, this class right here, by the way, which is me, should I sleep as if I am a student or should I sleep as if I am an instructor? And you don't have a way to specify which you want, okay? And this is called the deadly diamond. So this joke worked better when I was actually in grad school because I was teaching EECS 494 and I was a master's student at the exact same time, okay? And so biologically I was just very confused during that era and very, very tired. But this is the situation you can get into. So multiple inheritance just isn't really a thing we're going to be doing, okay? Deadly diamond is a big concern. We need a new approach. We need a new way to think about reusing code, okay? And composition is here to help us. Components, breaking logic out into these little bubbles that you can then just suction onto an object to get its functionality, okay? Whereas inheritance is an is-a relationship, right? You are, or Austin is a student. Austin is an instructor. An instructor is a human. A student is a human, right? Instead of an is-a relationship, composition is about a has-a relationship, okay? Has-a. Have you ever heard the phrase, if it walks like a duck, if it sounds like a duck, if it eats like a duck, it's a duck? Have you ever heard that phrase? Okay? It's this idea that what you are is defined by the things that you do. Okay? And that is the spirit of composition. Okay? Entities are made up of components that individually provide functionality. Okay? This is how they tend to be organized. You tend to have some sort of entity or actor data structure, and the only thing this is, okay, is a list, a vector of components, okay? That's all it is. You are nothing more than the components that make you up, okay? This is in Unreal Engine called the actor class, okay? And so you might have an actor that is the panda, or you might have an actor that is the snake. Now you're going to have a component class, okay, that will have functions like start, update, cleanup. In Unreal Engine, these are event begin play, event tick, okay? And these components are going to be adjectives, okay? Icy, fiery, okay? Maybe a render component that allows you to render. In Unreal Engine, this is the static mesh component, okay? And in a Unity, it basically looks like this, okay? Right, you've got a component, it's textual, okay? It derives from monobehavior, which is just a synonym for component, okay? Yeah, if you look at this component right here and you ask, what does it do? What does it do? What does it do? Well, it grabs the transform component on the game object. Remember, this is in Unity, so it's a bit different, okay? And then it uses that transform component to remember where our initial position is. Every single frame, every update of our game, we then move on the sine wave, on the sine curve, up and down around that initial position. This component will allow you to make anything levitate. You can put this on an enemy, like you see right here, but I can also take one of these ground blocks, slap the component on it, and suddenly we get sine wave movement, okay? And that's the genius of it. That's the benefit. You create a component once and you can pop it onto any actor you want. And you just get the functionality, okay? And so let's try and build our previous game with the pandas and snakes using a component-based approach, a has-a approach, okay? This panda right here has a bunch of features, okay? You can't have a panda without fur, right? So you might have a fur component, okay, which makes the image look a bit fuzzy, okay, and a little bit furry. Now, a panda eats meat, right? So you could describe it as a carnivore, okay? By the way, is a panda a carnivore? Does anyone know? There's a different way of describing it, okay? A panda is a living thing, and so it has health, it has energy, it has hunger, right? It has restroom, it has hygiene. And so in this component called living, we would probably put all those statistics in the form of variables. We'd have a float for health and a float for hunger and other stuff, right? We want the panda to be visible, so we probably have some sort of render component that does the actual rendering to the screen. But look at this. We also just gave the panda a herbivore component. What happens if you give an actor both a carnivore and a herbivore component? What have you just created?
Omnivore.
You have created an omnivore, okay? Bingo, okay? And if you want to create a bloodthirsty panda that is not interested in bamboo, you just get rid of the herbivore component, and now you have a carnivorous panda, okay? Forget that bamboo. Now, if you want to create an ice panda, what you will typically do is you'll take all these components that comprise the panda and you'll add on an ice skin component. That's how it works under the hood, right? This is literally just a panda that is rendered a bit differently, okay? Thus, it looks icy. If you want to create a Lovecraftian panda, what do you need to do? You take all the panda components, maybe you get rid of herbivore, so it only wants flesh, and you give it a zombie skin, similar to the ice skin component, and you give it a flying component. That spawns in the wings and gets us flying, okay? What about the snake? Well, we probably have a scales component, because it is a scaly creature, a poisonous component, because a snake is poisonous, and that ice skin component that we used on the panda can be reused here on the snake, okay? And so, we've completed our objectives, and it wasn't very hard, was it? If you have all these components finished, right, you can easily create these things. Compare this situation to the left, the HAZA approach to reuse, to the IZA approach to reuse on the right, okay? One of these is way easier in a game development context, okay? In an XR context. You know what's the old questions, right? Where does the ice snake go? That's a question we don't even answer anymore, okay? We just think about what components do we need. Oh, some of our existing components will already work, okay? You might ask yourself, oh, what happens if the ice panda melts? How do you take this ice panda and turn it into a regular panda in the component-based approach? Anyone know? Yeah.
Just remove the ice skin.
Yeah. You just say, I'm just going to take this ice skin and get rid of it. Or you can just turn it off, usually. In Unity, you can do either, turn it off or remove it. In Unreal, I think you can do the same. And boom, at runtime, you now have converted an ice panda to a panda. That easy, okay? That easy. Okay, bonuses. How do you make a scaly panda? Well, once you made the scale component for the snake, if you wrote that component really well, a high-quality, reusable component, you can take it off the snake and just pop it onto the panda, and now you have a panda with scales, okay? And there you go. How to make a flying zombie snake. Take the zombie skin component off the Lovecraftian panda and the flying component, pop it onto the snake, and you're golden, okay? Just like that. This is how the adjective system works in Scribblenauts, the game I just showed you, okay? The reason every object in the game can have a fiery version is because there is a fire component that gets popped on to whatever game object you spawn in, whatever actor you spawn in, okay? Another amazing thing about this approach is that as you develop more components and as you make them better and more featureful and expressive and more performant, you build up this lovely toolbox of components, right? How many of you have at least like 5 or 6 components in your Unreal Engine project right now? right? You've been making component after component. Well, if you made the component really well, you might be able to reuse the component on other things, okay? So eventually you've got this gigantic toolbox, and guess what? If someone is on your team but doesn't know how to program, like you've got a game designer on your team, but they don't know how to program, they can now build new characters and features by using the components you wrote because you made this wonderful toolbox for them. They don't have to write a line of code. Amazing, right? Oh, just fantastic. But here's a question. There's actually an issue here. Can you see an issue? It relates to these two skin components, zombie skin and ice skin. Do you remember dry? Well, here we have two components, both relating to skin. Have we violated dry? We have. We violated dry. We've got skin logic that is duplicated in two different components, two different classes. Oh, we're back to the first problem, right? How are we going to solve this? Bingo! Inheritance. Oh my gosh. It is a dramatic twist in the story. As it turns out, inheritance and composition aren't rivals. They are complements. Okay? You can actually use them together to solve your problems when it comes to reuse and keeping your code dry. Okay? If you have multiple components that are very similar to each other, like all of your affordance components, which all have the interact function, you can have them derive from a base parent class, like affordance in your code bases, and thus you will eliminate your dry problem. Okay? So inheritance and composition are powerful allies. Okay? They are not necessarily in conflict. Okay? So composition, right, is a big deal. It is discussed in the famous Gang of Four design patterns book. And in particular, they tend to prefer it in most cases. Favor object composition over class inheritance. All right? On The Sims, okay, one of the ways that composition components were used is you see this radio over here? You can listen to the radio, right? Well, you can also listen to a TV. You can also listen to each other, other Sims. So one way you can go is I'm going to create a listenable component. And that component is going to do all the functionality for letting a Sim walk up to it, kind of stand there and increase their morale as they listen, okay? Their happiness, okay? Their entertainment rating. And there you go. You can then take that component, that listenable component, you can put it onto anything. This slide probably had a component. This bathroom has a component that I worked on. It's the waiting line component. So a quick bit of trivia. In the Sims franchise, if you tell one Sim to go do something with an object, like watch TV, and you tell a second Sim to run over and watch the same TV, whichever Sim reaches it first will do that interaction. But the second Sim, the Sim who gets there last, will get canceled, okay? And they won't do anything. They'll go walk away. So one of my objectives was to change that and allow our game designers to say, hey, we're actually going to let Sims kind of see that it's in use, and we're going to wait and hang out while it gets used. And then we'll walk up and use it when we're done. So I created this waiting line technology. It was really fun. So this line looks super straight, but I added features that will allow the line to like zigzag organically. One of my funnest bugs, my favorite bugs, okay? I had a waiting line tech that would basically just do some math to extend out in a wavy, curvy line with some randomness associated away from the object. Well, what happens if you have a wall? What happens if you have a wall like this and the object is right here? So the object is here, I'm standing here, and the person who's second in line is standing here. Where should the person who's third in line stand? If you're third in line, you have to be behind where I am right now, right? Now you'd expect the line to like curve out this way and go in an L pattern, right? Perfect sense, looks great. That's how they tend to work in real life. But no, you know how it worked? The bug was this. The sim that was third in line would see, oh, I'm third in line, and they would do this. Okay? And they would literally like face into the wall like this. Okay? And then when the line moved up, we would get to see them go. Okay? And it was ridiculous. Okay? It didn't look good at all. Well, it was funny, right? I think I have some footage somewhere of it. But no, eventually we had to do things where, hey, we're going to calculate the positions of each position in our line, but we're going to do raycasts between them. Okay, if there's a wall, we know we can't put our third place position behind the wall. We have to kind of start curving it to get to go out there. Okay. Anyway, so yeah, a little bit of trivia. So one question is, how do we get composition? Okay, and then chances are we're going to end the lecture a little bit early. Start out. So maybe I can walk around and help some office hours or something. But a question, how do we get composition? You already know there are really easy ways to get it. You choose a game engine that supports it, okay? In Unity, composition is the only way that you're going to be programming. It is very strict about this. Components are everything in Unity, okay? It is a very elegant engine in that fashion. It has one way it wants you to do things, and if you do things that way, it works like a glove, okay? And it tends to look like this, okay? In Unity, you click on an object, okay, like that red security turret, and you're going to see all the components that make things up. You can turn them on, you can turn them off, you can tweak the numbers inside of them. Good stuff, right? In Unreal, okay, things are a little bit different because Unreal allows you to program with components, as you can see. But it also allows you to put code onto the actors themselves, which I think is confusing. It confuses most students and Unity devs. 494 students who come to EECS 440 get confused by Unreal because it gives them more possibilities that they're not used to. But you can see here that this light switch right here has two components. The static mesh component, which renders it and makes it visible and interactable, and the AF toggle actors, which allows you to actually click on it, okay? Sorry. Static mesh component doesn't make it interactable, but it does give it physics and a collision volume so you can actually hit it with your line trace, okay? Choosing a game engine that already exists and supports components like Unity or Unreal is a great idea. Very, very recommended idea for most people, okay? If you want to make your own from scratch, okay, I want to build my own game engine from the ground up with C++, SDL, and a Lua-based component system, Lua components running on top of a C++ core. Then this is the kind of thing that we teach you how to do in EECS 498-007 Upper Level CS, the Game Engine Architecture course. The students are getting closer and closer to this, okay? Today, we're launching Homework 5, which is the first 2D rendering homework. So they're getting there. But there's a reason we need a 4-month class to get people to take this approach, okay? It's tough, all right? It is not easy at all. You can see here that we have two actors in this game, a background actor and another second background actor. Okay, we have other actors as well. These are just the two that I've shown you. And each of these actors has a transform component with an X and Y value, transform component, a moving background component, and a sprite renderer component with a certain sprite configured, the background image, the beautiful kind of purplish background that you see, okay? And so this is how we do it in our custom 498 engine, all right? How do you build a composition framework like this? Well, you can do it in C++, okay? And it's not as crazy as you might think. In fact, you can go to this link and you can download and mess around with this example if you want to, okay? But what you can do is you can start by creating those base classes that we talked about. You're always going to have like an actor-based class, which is a container for components, and you're going to have a component-based class, which has those important lifecycle functions. Start, update, destroy, okay? In Unreal, it's event begin play, event tick, that kind of stuff. You can then create components. So transform component, it derives from that component base class. It has a 0.3 data type. Okay, so an X, Y, and a Z, a 3D point. You can set the point, you can get the point. It is now a component that manages where you are in 3D space. Okay, so not too crazy. You can have an entity class. Okay, this is basically an actor class. Okay, that is just a container for a bunch of components. In this case, we can store them in a vector. Okay, and when you update, we're going to go through every component you have, and we're going to call that component's update lifecycle function. Okay, we have the ability to add components if we want to. Okay, of any type. It's templated on that class type T. And so when we create that component, we add it into our components vector, and we call that start lifecycle function on it. We can then return the pointer to that new component so that you can customize the component and mess with it if you want to. Okay? And in this example, you see right here, this main function, we're creating an actor. We are adding a couple components. Okay? We're then messing with those components a little bit, adjusting their data, printing some stuff, updating the components, right? Not that crazy. It doesn't take that much code to get a super simple component-based setup going. The hard part is to understand what components are, how they work under the hood, and most pragmatically, when do you want to use components versus something like inheritance, okay? So here's your summary. Here are your takeaways, okay? Components are a super flexible, like creatively empowering alternative to inheritance, okay? Inheritance is a bit inflexible. You can't really change it at runtime. But game engines and creative works like XR apps, they love components because you can pop things off and on and off and on and turn them off and turn them on again. You can mix and match them, and you can do this without writing any code at all. Once you've created the initial components, all you do is mix and match them. That's it. Okay, mix and match at runtime. Really good for any scenario involving adjectives or properties or experimentation. Okay, and you can use inheritance with components to prevent dry from being lost in your code base. Okay, if you have a bunch of components that are very similar to each other, like our affordances in our P1 code base, then you can use inheritance, and we did, to fix things up and keep things nice and dry. Okay, all right. So that's my talk on composition. Does anyone have any questions? Okay, yes.
You said C# doesn't support has or multiple inheritance.
I don't think it does. Maybe it does it?
No, I mean,
okay.
But you also said Unity uses like composition.
That's right.
So how does that happen?
Yeah, so multiple inheritance and composition, totally different things. Okay? And so multiple inheritance is this idea that we're going to use inheritance features of our language to inherit code and functions and data structures and variables from many different classes at compile time. Okay? This is really nasty because of the deadly diamond that we talked about. Okay? If you have a diamond structure where you've got a base class and then the children start to mess with that base class and then both of the children come in, then you have a very nasty time, okay? You can't decide which of the alterations from these child classes you want to use. And so composition is much more simple. It's all done at runtime, giving it flexibility. Now, composition is not necessarily fast, okay? In fact, performance is a little bit of an issue when you get into using tons of components. But components are very simple, okay? They are simply little bundles of functionality that you can pop onto an object. Sometimes the components mess with each other and interact with each other. Sometimes they don't, and they just chill there and do their job, and that's it, okay? But it all happens at runtime, whereas inheritance structures always, for the most part, happen at compile time, okay? So that's the difference between those two. They're very much different things, though they feel a little bit similar, right? Multiple inheritance is when the inheritance feature of your language is trying to get the benefits of composition, but fails. That's what it feels like. Any other questions? Questions? I think that is pretty much all that I have for you today then. So we didn't take our break. Instead of the break, you can chill. I'm going to come back in about 5 minutes, and I'm going to be walking around. If you would like to take, 30, 45 minutes of office hours, I'd be happy to help you with any feature you want. Just let me know, okay? All right. Thank you all so much for being here. I'll turn the music on, and good luck as you continue to work on Project 1, okay? Those P1 Gold features. Okay, everyone watching online, I will see you later as well. Take care all. Bye-bye.